Docker. I work on the Docker Enterprise Edition offering, and I have been working on it for the past 2 years, since almost its inception. The topic of our talk today is Kubernetes in Docker, and specifically how Kubernetes is integrated into the Docker platform, and what the offerings of Docker will do with Kubernetes as an orchestrator.
Hey, Alex,
Can you
move the mic close
to the mic?
Yeah, okay.
Thank you.
So just to repeat, yeah, that sounds better. The topic of today is Kubernetes in Docker, and how the Docker platform is going to be using Kubernetes as an orchestrator in the future. So the slides are not working. Apologies for that. All right. So the agenda is, first of all, we'll do a demo of Kubernetes in Docker EE. Unfortunately, I won't be able to do a demo of Kubernetes in Docker CE, mostly because the CE editions that will include Kubernetes are in Mac and Windows, and I have a Linux laptop. Apologies for that. If you want to see a demo for CE, feel free to refer to the DockerCon EU keynote. It's got a very thorough demo by David Cajot. After the demo, we'll talk about the general architectures of CE and EE and how Kubernetes fits into both of them. And then we'll dive into some more technical topics around how Kubernetes is used and integrated into Docker EE. Specifically, we'll talk about mixed workloads, where mixed workloads refers to the fact that workloads from multiple orchestrators may be scheduled on the same nodes. And we'll also talk about authentication and authorization in Kubernetes and the integration that we're planning to do with Docker Enterprise Edition. And after that, we'll probably do a lengthy Q&A section. So first of all, let's do the demo. I'm not sure how I'll do it with my hands, but I'll try. So here I have the cluster of the upcoming version of Docker Enterprise Edition. This is a sneak peek. We have now demoed this version in public. You guys are the first crowd to see it. It's not very different than the one we showed already, though. So right here on the dashboards, we'll be able to see the health of all of our nodes, and the health of workloads that belong both in Swarm and in Kubernetes. Right now, this cluster is a new cluster that I set up for here, so it does not have any workloads. You can manage users in the same way that you can with previous Docker EE versions. And then there's 2 sections for Swarm and one for Kubernetes, and these are about managing the individual Kubernetes and Swarm. Yeah, I think that looks better from here.
It's better.
Okay. Yeah, and the Kubernetes section is about managing resources. There are Kubernetes resources. The Swarm section is about managing the Swarm resources, and there's a shared resources section, which is about managing things that are shared between the orchestrators. And one such thing is nodes. In this case, we can see that we have role manager 1 and role worker 1. That means that we have a single master node in Kubernetes, which is also a Swarm manager on this cluster. And I was going to attempt to deploy something in Kubernetes, but I realized that the current cluster configuration is not the right way. So let me quickly change something. I'll talk about this feature very shortly. All right. So another thing we're integrating is the ability to deploy compose files as native Kubernetes workloads. So I'll just create something as a stack. You can select the deployment mode, which can vary from Swarm services to just normal containers, and then also Kubernetes workloads. And for Kubernetes workloads, you select a namespace where all these workloads will be deployed on. And I'll use this simple compose file, which we also showed in DockerCon EU. And I don't know if you guys see this. Is it too small maybe? All right, so this will just create a 2-tier application with a web front end exposed on port 80. And a database on the back. That's a MySQL database with pretty much no repopulated data. Actually, maybe this image has data. Sorry, take that back. Let's create a stack, and we'll see that a Kubernetes stack was created. Now, this is a native Kubernetes construct. It uses the custom resource definitions of Kubernetes to actually define something called a stack in Kubernetes. We can see that the stack is starting, and You can also view the compose file as part of the spec of that stack. We also have support for round tripping, so you can actually go and edit the compose file mid-flight and then deploy it again. And what actually happened through this deployment here is that we created deployments and the corresponding replica sets for these two tiers of the application. There's also Kubernetes services that were created as part of that. And if you're familiar with Kubernetes services, if you're not familiar with Kubernetes services, they're effectively a way to load balance between different workloads, different pods, as they're called in Kubernetes. So the service that was created for the front end will also give us a URL, which, sorry, I did not make a sacrifice to the demo gods. Something happened here. Yeah. Sorry, we cannot see the artwork. And I also close the wrong tab. Okay, so this is a quick overview of what we're currently doing in Docker Enterprise Edition. Another set of features is how you use the CLI of both Docker and Kubernetes to navigate these features. So we do this through the client bundle feature. When you generate a client bundle, you download a zip file that includes certain certificates. And probably be tricky. So I just extracted the zip file that I downloaded from the client bundle feature as the current user that I am, which is admin. And as you can see, what that includes is a set of certificates and public cert, a private key, and the public cert of a CA that we can use to authenticate to Docker Enterprise Edition. And that means being able to authenticate to both Docker and Kubernetes. So if I source a script file that is included there, now my Docker command line tool is pointing to my Docker EE cluster, and I can see these two nodes that are part of that cluster. And if I point my kubectl tool, I can also see these same nodes as being part of a Kubernetes cluster. So if I were to do kubectl get pods, I'd be able to see the pods of the compose file that we deployed earlier. If I do docker ps, and I actually try to grep for one of these pod names, I will be able to see the containers using the Docker API, and using the container ID, you can even do normal Docker operations, such as getting the logs of one of these containers with Docker, even though it was deployed with Kubernetes. So this is how we would use Docker Enterprise Edition from the command line interface. You're able to use both the Docker and Kubernetes command line tools, and all the operations you would perform are restricted to the user for whose client bundle you just downloaded. All right. Any questions on the demo? All right, let's move on. Okay, so let's talk about the general architectures of both CE and EE that allow us to do this. First of all, in Docker CE, Docker CE by itself is supposed to run on a Windows or Mac machine. On the bottom layer, there's HyperKit or Hyper-V. On the bottom layer, there's the hypervisor that provides us with a single VM so that we can run Linux containers in an isolated environment that is usually provisioned with either HyperKit or Hyper-V. There's also VPN-Kit that enables networking to work seamlessly through the host, and there's also an adapter layer for host file system mounts. If you've ever used Docker for Mac, you probably realized how you probably have not really seen even how seamless the integration from the file system inside the VM is. Well, I know I've never paid attention to it when I use a Mac. So the big block in the middle is what is actually the Docker CE edition. It features a single Docker engine isolated in a very minimal virtual machine. And in the upcoming version, that single engine will allow you to enable swarm mode using the existing features that we have today if you do Docker swarm init. And you can also use the if you enable what we'll call kube mode, or some other name that is appropriate, which has not been fully fleshed out yet, we'll use the kubeadm tool to install Kubernetes, and also on top of that deploy the compose adapter layer that we just saw for the enterprise edition. And on top of that, you'll be able to talk to this local environment using both the Docker and the Kubernetes command line tool. So ideally, the install flow would look like I just installed Docker for Mac, and I enable Kubernetes mode, and now my kubectl is pointing to my local node that I can use to play with and do whatever I want. So it's meant to be more of a development playground for Kubernetes applications, and effectively a way to test workloads on a single node. So that concludes CE. Before we dive in further, I'm going to talk about a couple of orchestrators, one of which is going to be Kubernetes. And first of all, let's define what an orchestrator is. There's several terms around there, but a container orchestrator specifically, I like to define it as a tool or a platform that allows a user to deploy containers on a specified infrastructure. And whether that infrastructure itself is also managed by the same tool and platform is kind of secondary. Some of them do, some of them do not necessarily. So the first orchestrator I'm going to talk about is Docker Swarm. This is the original Docker Swarm that existed before Engine 1.12. Its code lives on the Docker/Swarm GitHub repository. It features a cluster-wide imperative API that is based on the API of a single Docker engine. That means that if you do Docker run in a container image, then that single Docker run command will be dispatched to one of the nodes on the cluster, and the container will be created there. However, if that container goes down, that Docker run command does not define that you need a declarative state of one container running at all times. It just means, hey, run this container once. And that's the difference between imperative APIs versus declarative APIs. So Docker Swarm features high availability. You can have the notion of multiple swarm managers that can discover nodes using some sort of a distributed key value store backend. The most popular ones are ATD and Console. And it also holds, the managers hold the entire state of the cluster in their memory. So they have a cache, and the leader is responsible for updating that cache. And in that cache is the full set of containers that are currently on the system, the full set of volumes, the full set of networks and everything across all nodes of the cluster. And finally, when Docker Swarm needs to make a scheduling decision around whether a container will fit on a node or not, that scheduling decision will be based on the reservations and limits of all the containers that Docker Swarm can see in its cache for that one target node. All right, so the next orchestrator is Docker Engine with Swarm mode enabled, not to be confused with Docker Swarm. It's the orchestrator that lives on the Docker Swarm Kit repository. This one has declarative state through the service construct, meaning that you can specify a service with a desired number of replicas. And if for any reason your system and your entire cluster is not running as many replicas as you'd like, the orchestrator will reconcile the state of the system and will launch new containers to make sure that the desired state is satisfied. And if you have, for example, 3 out of 3 replicas as defined in the service construct. It also features a built-in routing mesh with overlay networking. That means that containers, services can talk to each other and discover each other through isolated networks that are defined as first-class objects. You can create a network and attach 3 services to it, and then create a separate network and attach 3 different services to it, and these pairs of services now do not have access to talk to each other. There's also a routing mesh feature, which means that any node that has any service that has exposed ports to a host can be routed to from any of the other hosts on the cluster. In Docker Engine with Swarm mode enabled, scheduling decisions are based on the reservations of all Swarm services across all nodes. That means that this orchestrator is not aware of workloads that have not been scheduled by itself. It's very greedy in that sense. It also features an in-memory raft store that holds the distributed states. It does not use an external discovery backend like ATD. Instead, the raft store is implemented by itself into the Docker engine, and when you Docker swarm init, that RAF store is initialized by itself. The implementation of the RAF store is actually the same implementation as etcd, but it's not really a key value store. It's an object store that is tailored specifically for the needs of SwarmKit in this case. There's also a built-in CA and some other very neat security features that are personally my favorite thing about this orchestrator, which are that each node has their own unique cryptographic node identity, and when a node joins the cluster, they're issued a certificate which uniquely identifies that node, and they can use that certificate to establish mutual TLS with any other component in the cluster, and the cluster will be fully aware of who this node is and what they're supposed to be doing just from their node identity. And finally, the third orchestrator is Kubernetes. Well, it lives on the Kubernetes GitHub repository, or kdas.io/Kubernetes for Go packages. In Kubernetes, the fundamental scheduling unit is not containers, but is rather pods. A pod is effectively a group of containers that share the same lower level kernel features, so that they sort of feel like they're on the same host. That means that C groups and namespaces are shared between all containers on the same pod. So if you have a database container and if you have an application container running on the same pod, the application container will be able to just ping localhost on a specific port and reach the database, because they share the same network namespace. So they're, from the viewpoint of these processes, they think they're on the same host. Kubernetes features a declarative state through the notion of controllers, and controllers manage a specific number of pods on the system. Examples are deployments, replica sets, and daemon sets. It's effectively being able to express things such as, I would like one pod to be running on all of these nodes, or I would like 5 instances of this pod to be able to run on nodes that satisfy some specific criteria. Kubernetes has a flat networking model, meaning that it does not distinguish between networks as a first-class object, and the implementation of networking in Kubernetes is delegated entirely to plugins. So if you want to use some sort of networking fabric for your Kubernetes installation, you have to install the CNI plugin, as it's called, into Kubernetes, and then that CNI plugin will be called by Kubernetes to assign an IP address for every single pod. And it's the responsibility of the networking fabric to configure the nodes so that traffic is routable between the pods that it's supposed to be routable in between. Finally, the scheduling decisions in Kubernetes are based on the usage reservation and limits of Kubernetes workloads. Kubernetes is very efficient at packing workloads together on the same nodes, but in the same case as SwarmKit, it is only aware of its own workloads. And also it's monitoring the live usage of resources on a node through the C-Advisor tool, which is a native C group monitoring tool that is built into the Kubernetes node agent called a kubelet. All right, enough about orchestrators, actually more about orchestrators. So this is a general architecture of how Kubernetes fits into Docker Enterprise Edition. This is not really a very detailed architecture diagram, it's more architecture. The bottom layer is always a Docker engine. Every single node has a Docker engine that is the fundamental unit upon which Docker Enterprise Edition sits on. And then in the middle is the control plane product of Docker Enterprise Edition called Universal Control Plane. And that control plane product includes all 3 of these orchestrators we talked about. So you have Swarm mode for services, you have Docker Swarm for single containers, and you have Kubernetes for Kubernetes workloads. In this case, as an implementation detail, Docker Swarm and Kubernetes share the same etcd instance, which is managed by Universal Control Plane. And other features, other components that are included in Universal Control Plane include a node agent and reconciler pair. This is how we ensure that each node is running the components that it's supposed to with the right configuration. It also features a CA, which is used to issue these client bundles that we showed you earlier. So effectively that CA issues user certificates. And we also have an authentication system which serves as an OpenID Connect provider. That also has a database as a backend and stores the full set of users. And it also allows integration with third-party directory services such as LDAP and Active Directory and things like that. So on top of the universal control plane, we have either client tools such as the GUI, the Docker CLI, or the Kubernetes CLI, or we have the trusted registry of Docker Enterprise Edition, which sits on top of universal control plane and manages registry components and gives access to other security features and secure supply chain features. All right, so some highlights from that architecture is that Kubernetes is unmodified. It's literally a vanilla Kubernetes that's based on upstream with no changes to its code other than plugin interfaces. All the nodes that happen to be deemed as manager nodes are also Kubernetes master nodes. So that means that the management components of the platform are running on the same nodes at all times. And the SwarmKit node inventory is the source of truth for these nodes, meaning that if a user wanted to use the SwarmKit commands to promote or demote a node, that node would also become a Kubernetes master, or would stop being a Kubernetes master together with that operation. Finally, cryptographic node identity and MTLS, which are some of the strong suits of SwarmKit, they're used to secure the Kubernetes installation as well. So the node certificates issued on each node are used to then secure the kubelet on each node and allow it to communicate back to the Kubernetes API server. And the UCP agent reconciler pair is what manages the lifecycle of all of these components. Most importantly, if a node changes its state from manager to worker, the node reconciler will make sure that only the appropriate system components are running there. So for example, if you demote a node, all the sensitive material like root key replicas will be removed and so on. And it also works to validate certificates. So if a certificate is about to expire, it would renew it. If a certificate does not have the right SANs, after a configuration update, it would change it, and so on. All right, so the plugin interface is that we will support and expose with Docker Enterprise Edition. The Kubernetes interfaces would be the native API extensibility, meaning you can use custom resource definitions, you can plug in your own API in the same way that Kubernetes supports out of the box. Some of the Kubernetes components will have their flags actually exposed for users to modify. Not all of the flags will be available this way, but we're planning to expose most of them. And for the networking side, we will allow support for any user to bring along their CNI plugin. So if you're installing on Amazon, you can use the Amazon CNI plugin. If you're installing on your own VMware infrastructure, you can use a VMware plugin, and so on. And also we have open support for most ingress controllers that Kubernetes supports. And if you have a specific preference for your environment, you can bring that along to Docker Enterprise Edition. For storage, we will support Docker volumes as a type of flex volume driver in Kubernetes itself. So you would be able to create a Kubernetes pod that actually mounts a Docker volume, and that is something we're planning to have for this next release, also for C, not just for E. And in the future, when the container storage interface matures more, we're planning to converge into that. Finally, for metrics, you can use either Prometheus, you can scrape the native Kubernetes Prometheus endpoints that are available, or you can use Heapster to do your own metric aggregation. So let's talk about some topics on mixed workloads. And by mixed workloads, I mean workloads from multiple orchestrators that happen to land on the same node. It's what we call internally as mixed orchestration. So the first and most important topic is resource contention. What happens when you have multiple orchestrators using the same nodes is that inevitably they will eventually have different ideas of what the node is currently doing. So this is tracked by the notion of allocatable resources. So allocatable resources for a node is the set of CPU and memory resources that are available for scheduling on that node by the given orchestrator. And when you have multiple orchestrators, that means that this calculation is done differently every single time because the orchestrators are not necessarily aware of each other's workloads. So what happens is Docker Swarm, out of the 3 orchestrators we have, is actually the most respectful of other orchestrators because it looks at its entire cache for workloads and will respect existing CPU and memory cgroup limits. But that container cache may temporarily be stale in some circumstances, so there's a 10 to 20 second interval where Docker Swarm might actually schedule a container on a node that does not have the resources to support that. The story is very different for the other 2 orchestrators. Docker Engine with Swarm mode is only aware of its own reservations, so if you have anything else running on these nodes, it will keep piling more work onto them. And Kubernetes has an amazing way of handling out of resource situations, but it is only doing that for its own workloads. So also Kubernetes is not aware of system daemons or background workloads that are not launched through Kubernetes itself. So what happens when a node reaches its capacity for either of these resources is that for CPU, all the CPU shares are throttled equally for all the processes, so all your workloads will start slowing down. For memory, the operating system will launch the out-of-memory killer, or the killer, and that's a process that is designed to start killing other processes based on the scoring algorithm, which takes into account how much memory the existing process has, but also some other factors. So it's not easy to use the killer deterministically to actually give priorities to processes. So all of these orchestrators will actually reschedule when a workload is killed, but that could cause potential workload interruption. So if, on an environment where there's no consideration of how resource contention is handled, all of the orchestrators can effectively pack a node to its max, and then the workloads that are on that node will keep restarting and being rescheduled on other nodes, and it will not have a good life of time. So what do we do in Docker Enterprise Editions? We offer this feature that I sort of used earlier called Orchestrator Selection. So all of the nodes are running all of the system components. So on a worker node, you'll be able to have the kubelet running, you'll have the Swarm, classic Docker Swarm agent running, and the Docker engine and Swarm mode enabled. And an administrator at a higher level can toggle which types of workloads should land on this node. So for example, you can say, in this example, we have the manager node, which supports both Kubernetes and Swarm, and we have 3 worker nodes, one of which supports Swarm orchestration, and the other 2 of which support Kubernetes. So in this case, when we try to deploy a Swarm service, that Swarm service will not be schedulable on the 2 Kubernetes nodes. And we use native scheduling constructs of each orchestrator to enforce that. For example, we label these nodes, and when a user tries to create a deployment in Kubernetes, we would inject a node selector to only schedule on these nodes that have the Kubernetes selection. And another topic in mixed workloads is interoperability of workloads across orchestrators. What we're planning to do is currently not stitch layer 3 networking between Kubernetes and Swarm. The reason for that is while Swarm has a very opinionated and specific way of doing layer 3 networking through libnetwork and overlay networks, there's a lot of options in the Kubernetes ecosystem. So trying to bridge these 2 at that level would require an ad hoc project for each one of these networking fabrics that Kubernetes users use, a lot of which happen to also be proprietary. Instead of that, we're aiming for a story around bridging at layer 7, so you can expose your ingress controller in Kubernetes to also be an ingress in a Swarm network, and you can use that ingress controller as a bridge at the HTTP layer or whichever application layer you're using to route between workloads of the 2 orchestrators. And the same applies for DNS. You can have a central DNS server that is external to both orchestrators that actually serves DNS hostnames for workloads and all of them. And finally, for storage, I mentioned this earlier, we're planning to have support Kubernetes workloads with Docker volumes through the Flex Volume Driver plugin. that is landing in both C and E soon, and I wouldn't be surprised if it's actually open source, maybe already, I don't know. All right, so the last topic I will talk about is Authentication Authorization. Docker Enterprise Edition is very heavy on how we, very opinionated on how we treat users, and everything is done in the context of a user. We like to pride that it's impossible to escalate from a non-admin user to an admin user, and it's we like to think that it's also impossible to jump into a neighbor's container if you don't have permission to do so. So this is pretty much the whole life cycle of a request into Docker Enterprise Edition, if that request is aiming for the Kubernetes API server. So let's first examine the columns that we have here. We first have the client. The client can be either a user interface client or a kubectl client, which is the Kubernetes command line tool. Then there's the UCP controller, which is the entry point for such clients. It serves as a proxy for most of these requests. Then we have the OpenID Connect provider, which is our authentication server service. And finally, we have the Kubernetes API server in the end. So the way a request would flow to create a pod or perform some other Kubernetes operation would be, first a request goes into the UCP controller, and that request carries either a client certificate through mutual TLS, such as what we showed in the command line demo just now, or it would carry a session token if it's a UI request. And then the UCP controller will use these credentials to obtain a session for the current user, and then using, sorry, do you have a question?
Yeah, can we replace this with our own authentication framework, like in a big enterprises?
In Docker Enterprise Edition, no, it's integrated into the framework itself. However, if you have a directory service, which happens to be using LDAP or Active Directory, and I think we're also planning to do OAuth in the near future, you could use the directory service and tie it to our authentication system instead. So in that case, what was that? Yeah, so we use the credentials the user provided to obtain a session for them, and then exchange the session token for an identity token. And then we use that token, we plumb it back to the request that the user gave us, and forward this request to the Kubernetes API server. Now, the Kubernetes API server has this plugin called the OIDC plugin, which is used to validate tokens based on a specific signer that has issued these tokens. So the Kubernetes API server is aware of what a token issued by the OIDC provider looks like. So it knows whether it's valid and can verify that it's signed. So at that point, if those checks pass, we're done with the authentication layer, and the Kubernetes API server knows who the user is and has authenticated the request on behalf of a user. If anything fails above that line, the user would get back a 401 error, which is an unauthenticated error. Sorry, it's an unauthorized error, but the terminology is weird with these HTTP codes. Finally, when we get to the authorization part of the flow, the Kubernetes API server would actually call back to the UCP controller to use the existing role-based access control system that exists in Docker Enterprise Edition today, and request whether the user is authorized to perform a given operation. And if the user is authorized, the API server will be informed of that. And there's actually one difference that is, yeah, I should have updated this diagram. Instead of using these custom initializers that I'm mentioning at the bottom, we're using this feature in Kubernetes called admission controllers. So we do some further steps to mutate the request of the user as it goes through the Kubernetes API server before returning an OK response to the user. So these mutations will be things like ensuring that the user can only create things on nodes that they're supposed to be scheduling things on, or ensuring that the user is not trying to create something that will allow them to create a container with super user access on a node if they're not permitted to do so. With the existing RBAC system that Kubernetes has, it's currently possible to, if a user has permissions to create a pod, in the majority of cases they also have permissions to create a pod with privileged mode, as we call it, that is able to then escalate to root on a given node and then by extension the cluster in most cases. So we have admission control that prevents this from happening in Enterprise Edition. And yeah, that was pretty much it. In summary, Docker will include an unmodified Kubernetes distribution both in C and E. The issues around resource contention will be mitigated through workload separation and through selecting of orchestrators. And specifically in Enterprise Edition, Authentication Authorization will be integrated through the standard plugin interfaces that Kubernetes provides. All right, you want to sign up for the beta? This is the URL. Thank you very much. Questions?
Does this make Minikube project obsolete?
The Minikube project has a different set of use cases. It's about spinning up a single node or multiple nodes of in VMs on your local machine. So if you wish to keep using VirtualBox or keep using KVM, if that's preferable to you for any reason, or if even you have an AWS driver for Minikube, those use cases will not be satisfied by Docker for C. Docker for C is about having the ability to, on the same VM as Docker, also run Kube. So even though there's overlap in the use cases, these projects have different goals and different visions.
Yeah, I mean, I came in late, but on your meetup you discussed about container D. So did you cover that container D? And
no, the next speaker will cover the integration with container D.
Okay.
In this case, yeah, it's going to be in the next talk. For now, in this version of Docker Enterprise Edition, we're assuming that the runtime interface is the Docker daemon as it exists today, as of version 1706 or earlier. Yeah.
Does it support multi-master deployments? Like it's not single.
Yes, yes. So in Enterprise Edition, we'll support multi-manager deployments, and these deployments will be managed by the SwarmKit node inventory. I can actually show you. I don't know if this will be helpful, but in SwarmKit, when you want to have a multi-manager installation, you go to you use a manager node to promote a non-manager node. So we can do. There's a bug in this release. Sorry.
Any best practices completed towards like a federation?
Sorry.
Any federation has been certified towards your I don't know Kubernetes and Docker, like a federation cluster.
A federation
multi-cloud and then on-premise.
Oh, in this release, we're not exploring the idea of federating multiple Kubernetes clusters. We're assuming that the Kubernetes cluster that comes in with Docker Enterprise Edition will be managed only by Docker Enterprise Edition on that same node. But it's a very popular use case, so I've heard of this before.
So,
Yes?
so I have two questions basically. What's the Docker's aim having two competing products underneath the same umbrella?
Well, it's actually three.
And the second question is, what is this? When will be available? What's your target GA date?
Yeah. So for the first question, the reason why we have so many different things that do cover the same functionality is we want to offer choice to customers. We think that the bigger value out there in the ecosystem is not in providing the best orchestration solution, but rather in providing an enterprise solution for customers who don't even want to have to make the choice in the beginning of their journey into containers about what the orchestration solution should be. So having multiple orchestrators allows us to talk to enterprises, and they can be reassured that no matter which orchestration solution ends up filling their needs, that's the one that they can use with our platform. And for the second question around release dates, we announced that we're planning to do it in early 2018. Yeah. I would say that we're on track, we're doing good work, don't worry about it.
Question on the, you said the Kubernetes will be bundled or modified, so what is the specific version, or it will support any version?
Yes, we have already been certified as Kubernetes 1 versus 8 conformance, and that's the version we're planning to use for this release.
I think, so moving forward, you all have to use one that bundle together, is that the idea? Like
Sorry, what kind of bundle?
Like you mentioned the certified 1.8, so later on maybe they have this 1.9 version without automatic work, or it need to be certified again?
Well, we would need, if Kubernetes 1.9 comes out, we would need to first integrate it into the EE platform and then ship a new version of the EE platform with the 1.9 version. And as part of the release process, we would also attempt to get certified before that release is even out the door.
So it sounds like it would be like today, when you install Kubernetes, you have to use the Docker covers Kubernetes. So
Yes.
it's similar to when you use a Docker version, you have to use a Kubernetes comes with Docker. Is that right?
Yes, if you want to use, well, it's the same Kubernetes version. We're going to be shipping Kubernetes 1.8. If for some reason you happen to change the images that we use and bring your own 1.8 Kubernetes images, it will work exactly the same. It's just that the version and the installation flow around that version that we'll have in the enterprise product will be certified and authorized and bundled into the enterprise package as a whole.
Okay, got it.
So,
Yeah.
which orchestration is Docker recommending if somebody is starting new?
What is your target? What do you want to do?
So you say, I mean, if I'm not sure, like, so I did not clearly giving an indication like, oh, which one I should use, and even the Docker comes with one strong one and another one is strong.
Yeah, so I would say it depends on what use case you have. If you want to run, the same testing instance several times without any of your testing environments being affected by each other and only being able to communicate with each other, I would argue that Swarm mode is the best orchestrator for you because you can create unique overlay networks for that. In Kubernetes, you have to create separate namespaces, and then depending on the CNI plugin that you have to create network policies to prevent connections around these namespaces. And then you have to change context between all of your deployments instead of having a big compose file or allowing to change the way that you deploy all these different types of pods. It would be too complicated, but there's more complexity around it. On the other hand, Kubernetes is ideal if you care about resource utilization. If you want to if you want to use your hardware as efficiently as possible and to have your orchestrator pack the very last byte of RAM as efficiently as possible, Kubernetes is probably ideal for that. It has a lot of features as to how to properly handle out of resource scenarios, how to determine when a node is under pressure of certain resources. Yeah, there's pros and cons in both cases.
Like you said, the Swarm orchestrator is not aware of the Kubernetes one.
Yeah.
And the Kubernetes scheduler said it's not aware of the Swarm. If this is true, then you cannot have optimal scheduling of task scheduling on the nodes.
Yes, so that's why we're restricting task scheduling to one orchestrator for each node. So that means that even though the node agents, the cluster, well, we're addressing this problem not at the cluster definition level, but at the scheduling level. So if a node, let me rewind actually, each node will be running components for each orchestrator, but each of the nodes can have workloads from only one orchestrator. So if you want to switch the scheduling mode of this orchestrator from Swarm to Kubernetes, you press a button. I actually accidentally showed it in the UI, and when you press that button, all the existing workloads will be evicted, and now that node will become a Kubernetes node. Let me show you how it looks in the UI. So if I go to my nodes, if I go to this worker node, and we go, you can see that the orchestrator has been set for Kubernetes on this node. You can actually go and change that to Swarm. And if you select mixed, we throw a warning and we'll have a lot of detailed messages as to why not to use mixed orchestration in production, but we do feel it may be valuable for proof of concept installations or environments where users really know what they're doing, so we still have it as an option. In the future, we would want to work with the upstream projects of all orchestrators to try to get us to a state where mixed orchestration is actually feasible and each of the orchestrators can actually understand each other. But that's more of a long-term goal.
Is that how Docker CE will work, like on the Mac?
Docker CE will be, since it's a single node, it will be only mixed. So you can deploy both Swarm and Kubernetes workloads on it. Yep.
So the mixed here, you can only that's the only type that you toggle between the two? Or, so you said you could switch,
Yeah, there's three modes. There's Swarm, there's,
so that never can change to Kubernetes, right? Like,
it can.
Oh,
If you're
okay.
in Swarm, you can go to Kubernetes. If you're in Kubernetes, you can go
So
to
it's-
Mixed.
Okay, I guess I don't understand the difference between mixed and, if you can change all of them to, eventually to one or the other, then.
Well, Mixed means both, effectively. It means both Swarm and
Oh, okay.
Kubernetes. That's what it means.
And you also
Oh.
mentioned that when you switch orchestrators, you also evict the workload
Yeah,
for the
yeah.
other work, so.
So if you were in Kubernetes and now you were to switch it to Swarm, all the Kubernetes pods would get evicted from that node and vice versa. So you would be guaranteed that there's no workloads from two orchestrators if you're only selecting a node to use one orchestrator for scheduling. That's how we get over the resource congestion problem.
I guess mixed has the disadvantage that you have to figure out how to organize that, the workload, or partially.
Yeah, if you're careful and if you know that you will never hit the resource limits of your node, then Mixed gives you more flexibility, especially if you're planning to use deployment formats from both orchestrators to deploy something on identical nodes, for example. There was a question on the back?
Yeah, I had a question. If you're using a managed cloud orchestration service like in Google, or let's assume Amazon comes out with a managed Kubernetes service, then is there a compelling reason to look at Docker EE or not really?
Well, there's other value adds than just Kubernetes. Well, first of all, this version of Docker EE is entirely self-contained, but we're exploring directions where we could use an external Kubernetes server at some point. Maybe in the future, and this is definitely not officially something we're pursuing, but I've heard of a lot of ideas where we could have Docker Enterprise Edition manage an external Kubernetes cluster and an external Swarm cluster, and then you get to decide how your workloads could be split between the two. Now, regarding value adds of Docker Enterprise Edition compared to an external, to a third-party service, we do have a lot of them. I can talk you through it, but I'm not sure if the whole crowd would appreciate it. One of which is our secure supply chain features. You can integrate your control plane with your trusted registry to ensure that only specific signed images are allowed to be deployed for production. And, well, for example, bear with me for a moment. You can go here, Docker Content Trust, set run only signed images, and yeah, if I create a team, then you can say that this team has to sign every image that can be deployed on this cluster. So there's integration with the registry there as well. That's one example. Yeah.
How about storage volume support, plugin support? Is it the plugins? All plugins will be supporting both the modes, or?
So all Docker volumes, including Docker volume plugins, will be able to be used for both Swarm and Kubernetes workloads. And Kubernetes plugins and Kubernetes volume types will only be usable for Kubernetes workloads. The reason for that is that Kubernetes is actively trying to move to a standard called the CSI, the Container Storage Interface. When that happens, we would love to adapt to that and use that instead.
Do you have something equivalent to a flex volume on Swarm?
In Swarm? I don't have the answer to that, sorry.
So, okay.
Yeah, I'm not familiar with the volume plugins we have by default in Swarm.
You have a service mesh embedded?
Sorry, the routing mesh?
So, routing mesh,
Yeah, so the routing mesh is embedded and still works the same way for Swarm services, but you cannot use the same routing mesh for Kubernetes workloads.
So can you run a HCO with Kubernetes and not affecting?
The plan is, yes, to be able to run Istio. However, if you're running both Swarm and Kubernetes workloads at the same time, it is a known issue that you might have to manually figure out port ranges for each orchestrator. But other than that, you should be able to run both. I've heard success stories. Any other questions? All right, thank you very much.